In this video, I'm going to show you how to get Prometheus metrics from your applications running in Kubernetes into a backend. I'll first show the kind of basic way, a single cluster, a basic setup, great for quick and dirty POCs, and then I'll show you how to actually productionize this and move beyond just a single cluster with an OpenTelemetry collector component called the target allocator. So, no time to waste, let's get to it. Now, we will eventually need a backend to send our Prometheus metrics to, so I'm going to start up my backend. I'm using OpenObserve as always. I can check that it's running by visiting localhost 5080, and it says, yeah, no data ingested. As always, I'm going to go into find out how to ingest data, go to custom, go to OTel collector, and I'm going to grab this whole piece here, and I'll show you why in a moment, but make a note of this basic and then this random token that they give you. Leave OpenObserve running and create a new Kubernetes cluster. Onto this cluster, I'm going to install a demo application. In this case, I'm going to use Cert Manager, but you can use whatever you like. So I'll just add the Helm chart and go and install it now. Okay, it looks like it's all installed. Let's have a look at things to make sure it's installed. Here's our cluster. And we have, if we go into network and services, we've got 3 services in the Cert Manager namespace: Cert Manager, CA Injector, and Webhook. So there are 3 different services, and hopefully that should correspond to 3 different pods. And all is running, all is well. Fantastic. Now, if we have a look at the Cert Manager website, go to documentation and then DevOps tips and then Prometheus metrics, you can see that they're on the standard /metrics endpoint on port 9402 of each pod. There is a Prometheus endpoint. So let's just double check that they are actually running. If I go in here and go to click the pod and go down and forward the port, I should get, yeah, not found on the root, but if I go to metrics, I get Prometheus metrics. Perfect. I'm not going to do it for all of them. I know they are running. Okay, so how do we get this data into our backend? Now, the first option, of course, is to just use whatever your observability provider gives you. They probably have an agent or an operator that you can just go and install. They've done all the hard work for you. It's opinionated, yes, but there's nothing to configure. So that's one option. The next option would be to specify each of these pods. But as you probably know, pods are ephemeral. So if these pods disappear, which they may well do in Prometheus, that's not going to get you very far, because the pods will disappear and your metrics will disappear, because whatever's scraping those pods, looking at that /metrics endpoint for the pod, won't be able to find it anymore. The good news, though, is that we have services in this case, and the services allow us to get to the pods. So all we need to do is figure out a way to select the services, and then we'll be able to get a route to the /metrics endpoint. So we need a component to go and do this scraping. I'm going to use the OpenTelemetry operator, so I will go and install that now. And then remember when at the beginning of the video I asked you to capture this information here. Use this and echo-n it and base64 encode it, and I'll show you why in a moment. And the -n is important if you're on Mac, because I found if you don't have that, what actually happens, Mac OS adds a new line character like that, and obviously that's not the authentication token, so it fails. So go ahead and encode this value. Let me do that again, just clear the screen. And grab all of that and put it into our secret value in here. So in this YAML file, again, we have a secret called OpenObserveKey, and we set a value of token to the encoded value. We use it down here. I'll explain that in a moment. Okay, save that file. Now let's double check that everything is running correctly in OpenTelemetry. Let me just have a look at this. We've got 2 services, and we should have a pod running. Okay, perfect. So that's the operator, but now it's actually time to go and install things. So kubectl apply otel basic. That will go away, and while we're doing that, I'll explain what is in this YAML file, because this is where the magic happens. Okay, up the top we have a service account. It is in the same namespace as the OpenTelemetry collector operator. It's called otel call. Then we have a cluster role. Now, this cluster role has many permissions like get, list, and watch the pods and the services and the endpoints. You can obviously adjust this to whatever you need. Then we have a cluster role binding. Again, you might just need a role binding. I'm not going to go into roles and cluster roles and RBAC in. That's a much, much longer video. But the role binding basically is the glue. It binds the cluster role to the service account. Okay, then we have a secret. That's the thing you adjusted before, and we're basically using that to store the API token that we need, that the collector is going to need once it has scraped the Prometheus metrics to push the data into OpenObserve. With all of that plumbing out of the way, we then get to the real meat of what we are here for, which is an OpenTelemetry collector. Now, when we apply this custom resource definition, the OpenTelemetry operator that we installed before is going to pick this up and spin up a collector for us. We're going to run it as the service account that we defined at the top here, otel call. That's why we need the service account, because this collector needs permissions to go and get services and get pods to actually find the endpoint. Then we set an environment variable, and we're pulling from the OpenObserve key the secret that we defined above, and we grab a token, the token value out of there. Why? Because we use it later on. Okay. Now we get into the OpenTelemetry collector configuration, and if you've configured an OpenTelemetry collector as a binary on your, just the normal binary, not in Kubernetes, this will be very familiar. We define a receiver, a Prometheus receiver, and this is a drop-in replacement for the Prometheus binary. So we have a scrape config, we're calling cert manager, we're going to scrape the /metrics endpoint every 5 seconds. But notice we don't actually give the endpoints. What we say is the collector should ask the Kubernetes API to look up the SD, the service definition configs, and find the right services. How do we tell it which services to find? Well, we are saying look for services that have a service label with a key of app, where the value is CA injector or cert manager or webhook. Any services that are labeled app and then CA injector, cert manager or webhook, please go and try and scrape the /metrics endpoint every 5 seconds. That's the magic. Then we, have some processors like a memory limiter for the collector to make sure it doesn't crash, and a batch processor to batch up those metrics in batches of 1,000 or 5 seconds, whichever comes sooner, and then send them out to our endpoints. OpenObserve, host, Docker internal, because I'm running a kind cluster, so I need to get out of this kind cluster, which is running in Docker, and get to my local machine, which is where OpenObserve is running, and I have my authorization token here and my stream name. Notice that that looks precisely like this snippet here. The only difference is I'm not putting this in plain text in my YAML, just in case I commit this to Git. I don't want a secret in my YAML file. And then we tie it all together. We're going to receive data on the Prometheus receiver, we're going to process it in some way, and we're going to stick it out into OpenObserve. So now that we understand what's running, remember we've got our Prometheus metrics endpoints. They are being looked at and scraped by the collector, and the collector is batching them up and sending them into our backend. So if we go now to home, we've got some streams, some data streams. Wonderful. That's good. That means we've got data. Let's go to metrics, and there we are. All of our metrics are available in our backend system. So what you've seen already is great for little POCs, single cluster setups, demos, that kind of thing. But as you start to productionize this, you're going to have multiple clusters, you're going to have multiple collectors, lots and lots of Prometheus going on, and you need to scale that. So, and this is where the target allocator comes in. So looking at the OpenTelemetry documentation, it describes the target allocator as a tool to distribute targets of the Prometheus receiver. That's good, that's what we're using, on all deployed collector instances. And it says it serves two functions: even distribution of Prometheus targets among a pool of collectors. Remember, we have 3 Prometheus targets in our demo. We've got 3 services. So the target allocator is going to basically, we've only got 1 collector instance, but if we had many, the target allocator's job is to say, no, you're too busy, collector 1, go and scrape from collector 2. And then its second job is discovery of Prometheus custom resources. What that means are things like service and pod monitors, which we're going to see right now. So let's jump back. I've restarted everything. You can see even OpenObserve has no data whatsoever. So let's get straight to it. Let's create a cluster. So while that's running, I'll go and do what I did last time, which is grab the base64, grab the API token and base64, encode it, echo-n, that, no, base64, that's the one, and I'll set it in the secret. Now I'm again gonna install Cert Manager, but this time notice I've got Prometheus Service Monitor enabled equals true. I'll explain what that does in depth later, but for now we need to go ahead and install the Service Monitor CRDs from the Kube Prometheus stack. Again, have a look at the video description. There'll be a repo with all of the copy and paste commands in here. So let's go ahead and install those CRDs. Now we can install our dummy app, Cert Manager. And once that's installed, let's just have a look at Headlamp again. We've got the 3 pods, they're running, and as always, we've got the 3 services. Fantastic. Now we can install the OpenTelemetry operator. And now that we've base64 encoded our value and added it to the YAML file, hopefully we can install the OpenTelemetry collector. Good, everything has been created. And if we look at Headlamp now, we should see that things are creating. Perfect, we're running. Now you'll see a collector and a target allocator. Now let's jump into the YAML and see what's going on. I'm not going to explain everything. We've got the same stuff basically. The service account, the cluster role, same as last time. The cluster role binding, the secret you've already seen. A lot of this is the same, but the place it's different is we set this scrape config. Notice we're not specifying what the services are that we want to scrape, because that happens in a separate component that we've installed. If we go to custom resources, and now we have a service monitor custom resource. So a service monitor is a custom resource that allows us to split apart and separate which services we're going to look at. So if we go to instances of these custom resources and make sure that the namespace filter is unselected, we can see there is a target allocator, certificate issuer. These are all the Cert Manager things, but the Prometheus operator now has a service monitor called Cert Manager, and if it's a custom resource called Service Monitor, and if we scroll all the way down, it's saying please monitor the metrics endpoint, scrape it every 30 seconds. For the target port HTTP metrics, we know that's 9402 from last time, and look for anything that has an app.kubernetes.io/name in CA injector, Cert Manager, webhook, or the instance is Cert Manager, or the component is in this list here. The end result is the same as last time, but with this separate custom resource, we can now enable other teams to actually define these service monitors, and there is also a pod monitor if you wanted to do that, but it's a little bit more separated, and also then the target allocator takes over and starts distributing our load. Now the question is, where did this come from? We didn't define this. You'll notice we only applied that YAML. The magic for Cert Manager was in the install command. So when we set this Prometheus service monitor enabled, Helm and the Helm chart actually went and installed that CRD for us. And that now explains why we needed these CRDs up front. Because if we tried to install Cert Manager without these CRDs, it would have failed because it doesn't know about service monitors. This is something extra on the cluster. So if you're just getting started, by all means define this all manually in the collector, but as you start to scale up, I would highly recommend you look at using the target allocator. My colleague Henrik Rexed has a fantastic deep dive video on the target allocator. Again, I'll link to that below. I hope this has been useful. Enjoy your observability journey, and I'll see you again very soon. Thanks. Bye.